Aloha, I'm Jim Hagerman, and this is my lab. Today I want to go over my investigation into the Zendrive pedal circuit. Why? Two things. One, last year I introduced my own D-style pedal, the Overdrive Special, which I had to rename to Overdrive Clipper because the Dumble Preservation Society threatened to sue me over trademark infringements. But that's another story. Secondly, JHS recently came out with their Not to Dumble pedal, and the fact that they cloned a Zendrive for the high gain channel caught my attention. I had to check it out. For the record, I am a big fan of JHS marketing, and I believe their Not to Clone solderless DIY concept was absolute genius. So much so that I came up with my own DIY pedal called Gamma Radiation. But I didn't stop there. I just couldn't help but dig into the Klon Centaur circuit. That study led to the Neoclon and TubeClon pedals, both of which were added to my DIY kit line. I've already made a video about them, which I will link in the description below. Anyway, back to Zendrive. What makes it so special? And does it really generate a D-style tone? I won't go through the entire circuit, skipping the tone control and output buffer, focusing on the clipping section. First, a look at the TS808, which I believe came before. You can simplify the TS808 by removing input and output buffers, removing the active tone control, and turning R5 into an adjustable voice control. The result is a nice, clean circuit, and it looks just like a Zendrive. Here is the unmodified Zendrive circuit with clipping diodes in the feedback network and adjustable gain and voice. That's when I noticed the way the MOSFETs were wired up with gate tied to drain. Genius! But then I realized, oh no, the diodes eliminate any forward mode of operation. Did this genius mode even work as I had suspected, or was it all in my head? By that time, Not to Dumble pedals were all sold out, so I grabbed an Ion Effects kit, which turned out to be very well made, and through-hole parts made modification easier. It went together perfectly and fired up on the first try. What did it sound like? How did it measure? Here are some screenshots of the various modes of operation. Let's look at the clamping diodes. By removing the op-amp, I could measure them in circuit, although in parallel with the 500K gain control. This is what the diodes looked like. The 2N7000 MOSFET by itself, then with a BAT47 added, and then with a 1N34A germanium diode added on top of that. Pretty much as you expect, with the MOSFETs operated in reverse mode using only the built-in body diode. I ran a bunch of computer simulations, and the results were pretty much identical to what I saw on the oscilloscope. Changing diode type did not have as much effect on the output as compared to the number of diodes used in series, which determines the ratio between hard-clipped and clean signals. It is this mixing of clean and dirty that gives a Zendrive its characteristic overdrive tones. Okay, so what about this forward mode of operation for the MOSFET? This plot shows its response in both directions, reverse body diode and forward VGS threshold operation. The significance here is that a single MOSFET can do all of the clipping itself without the need for any of the other diodes. Here's the modified circuit, which I call Genius Mode. As far as I know, nobody else has ever tried this in a Zendrive circuit until now. The sound remains mostly the same, but possibly a touch more dynamic to my ears. Simplified, for sure. For those with a Zendrive or a Not to Dumble pedal, you can add a switch that selects between modes like this. Yes, a Zendrive sounds wonderful, and I get why it's so popular, but is it really D-style? Let's back up a year or so. While designing my Dumble pedal, I could not afford to buy the real thing, an ODS amplifier, so I made my own. At least the high gain clipping section, which I believe is what we are attempting to mimic here. Something this complicated is not easy to simulate, as the tubes enter deep into grid current territory and saturation, which the models do not cover. Anyhow, here is the measured result of the Dumble circuit. It squares up even more when driven harder. Frankly, This waveform with symmetric clipping is not easy to achieve with tubes, and I believe due to the brilliance of Howard making the grid resistors exceptionally high in value, the circuit I use in my pedal is very different. Originally introduced in my PP12 amplifier, it is an all-tube circuit that clips via tube cutoff in both directions, an invention I named the Hagerman clipper. Here is the measured response of my pedal. Note, it is virtually identical to the Dumble response except inverted. For comparison, none of the Zendrive waveforms could replicate this, no matter how the controls were set. That's all for now, and mahalo for watching.